Hello everyone, welcome you all for this lecture. I am M.murugan from the Department of Marine. So today I am going to discuss the topic about alternators. So alternator nowadays it's a very crucial thing for the electrical generation purpose. So in order to know the alternator concept, so we are going for the overview of the construction details and the working principle and applications. So before we are going to know the alternator concept, first of all, actually what is produced in the alternator? It's a voltage. What is meant by voltage? That we have to know first. So voltage is nothing but, so in our basic physics we are already know that the atomic structure. So in the atomic structure we are having the protons, neutrons, and around the electrons are revolving. So the outermost orbit we are having the valence electrons or free electrons, you can call it as free electrons. So we can move the free electrons by applying some amount of force. If the proton or neutron in the center, so around the electrons are revolving. So outermost electron is called free electron or valence electron. So we can move that electron from one atom to the another atom. So all the material is made up of atoms. So that thing we are going to know first. So flow of electron is nothing but the current. Flow of electrons is nothing but the current. That we are going to generate now. So how we can move the electron from one atom to another atom? By means of applying some force. That force is called electromotive force. So we are going to generate or create the force to flow or move the electron from one atom to the another atom. That's why we are going for the alternator concept. So in general, in machines we are having or we are generating the alternating current. So based on applications, whether it may be a AC or DC. Now we are going to discuss about the AC generators or synchronous generators, or we can say that alternators. Alternators may be called a synchronous generator or AC generator. So first of all we are going to see the constructional detail of the alternator. So what are the things we are having in the alternator and how the electromotive force is generates, that we are going to see one by one. First, let you know the outline of this alternator. So have you ever wondered where does the electrical power comes from the vehicles? The answer is alternator. That's the thing, that is the main thing. Yes, there is a battery, but that is only used for the power for the starting purpose. In order to start the vehicle, we are using the battery power. An alternator is a type of generator that converts the mechanical energy into the electrical energy. That's the main thing. In the alternator, we are having a part which converts the mechanical energy into the electrical energy. What is happening actually? We are giving some mechanical energy, that is rotation. We are giving the mechanical energy, that is here rotation. We can get the electrical energy at the output. So in this way we are going to generate the AC supply. So mechanical energy is converted into electrical energy, is called the alternator. So the output of the generator can be either alternating current or AC or direct current DC. Okay, the alternator is a type of AC generator that generate only the alternating current. In general, suppose we are having the magnet, north pole and south pole magnet. In between we are having the coil, current carrying conductor. One law is there, often we are going to remember that law, Faraday law of electromagnetic induction. Faraday law of electromagnetic induction. So before going to the construction, we should know somewhat about the statement for the Faraday law of electromagnetic induction. What is Faraday law says that whenever the current carrying conductor, a normal copper conductor, if I place the copper conductor in between the magnetic poles, what is happening? Nothing is happening. The second statement of the Faraday law of electromagnetic induction says that there is a rate of change of flux occurs means, then the EMF is produced between the 2 points of the conductor. Not only we are going to place the conductor in between the magnetic field, we are going to change, or we have to change the magnetic field values among them. Then only we can get the EMF value across the 2 points of the conductor. That is the main thing we should know before going into the concept of the alternator. Then vehicles are powered by the direct current DC, not the alternating current AC. Then why we use the alternator? So all the vehicle nowadays, most of the things we are using the DC supply only for the electric train and the inverter purpose, household inverter purpose, we are using the batteries. Normally the electrical, we can't save the electrical energy, in battery. Then how the electrical energy is stored in the battery? By means of the chemical formation, So if we want a large amount of energy, we have to have the large size of the battery. So the electrodes, electrolytes and all, the more space is occupied to some amount of value. Suppose for example 440 volt AC supply means that much amount of voltage we need for that much hours, some long hours we need, means the size of the battery becomes very high. That's why we are going for the generators. So from the AC generator, we can convert the AC generator directly by means of the rectifier circuit. We can convert into the DC separate easy. But for the conventional DC generator, we are having the commutator. So all the generators are producing only the AC supply. For our purpose only, we are converting, whether we want AC or DC, we are converting into that level. So conventional DC generator having the commutator converts the bidirectional current into the unidirectional current by means of collecting the same amount of supply from the positive side as well as in the negative side. Okay. So what is alternator? That is the question, main question. What is the alternator? An alternator is an electrical machine that converts a mechanical energy into electrical energy in the form of alternating current AC. That is the main thing. It is also known as the synchronous generator or AC. That is already I told that. Also known as the synchronous generator or AC generator. There are other types of AC generators. We will discuss in the subsequent classes, and it generates specific voltage at a specific frequency. So normally in our country we are generating a 440 volt AC supply and the 50 hertz AC supply. Often we says that when we are calling the AC or when we are mentioning the AC supply, always we can mention that 440 volt 50 hertz AC supply. Why we are mentioning the 440 volt or 50 hertz AC or either three phase or single phase? We are going to mention that also. Suppose if you draw one circuit diagram, we are mentioning that all the things in the circuit diagram. Why? We should know first. Either it is a single phase or three phase, whether it is AC or DC. DC there is no frequency. If it is AC means what is the amount of frequency we are getting. In our country we are generating only the 50 Hz frequency supply, but in the foreign countries they are generating a 60 Hz frequency supply. So based on that we are going to work in the devices which we are going to use. Okay, so some of the generators are specifically designed for the specific voltage at the specific frequency. That's the main thing. Then, what is the construction of the synchronous generator? So, unlike DC generator that has the rotating armature winding and a stationary magnetic field. You may know about the DC generator concept. So, in the DC generators, all the generators are having two kind of windings. One is the armature winding and another one is the field winding. The armature winding is for collecting the current and the field winding is for injecting the current. So, in general I am saying field coil is for inject the current to the machine or it get the supply from the external source, but the armature coil it gives the current to the external. It gives the current to the external. Only these things we should know first. So only two coils, whatever may be the generator, all the generator having only two coils. One is armature coil and another one is field coil. So in the field coil we are injecting the current to the machine. In the armature coil we should get the current. Whatever may be the level we will discuss later. Okay, that's the first point. So the alternator is made up of stationary armature winding and the rotating magnetic field. So in the DC generator we are having two parts for the machine. One is stator and another one is rotor. So in the DC generator, in the stator we are having the field coil and in the rotor we are having the armature coil. So where we are giving the supply? In the field coil. So in the DC generator, the stator side we are giving the supply, from the rotor side we are getting the supply by means of the brushes. That's why we are using the commutator along the rotor shaft. What is the purpose of commutator actually? It converts the AC supply into the DC supply. So among are converting parallelly, it's rotating as well as converting the alternating current into the DC supply through the brushes. You can get the DC supply to the outside. So from the rotating armature we are getting the supply in the DC generator, but in the synchronous generator the concept is vice versa. So the constructional details we will going to discuss one by one. So the rotor field winding are connected to an external DC supply here. So rotor. So actually I am already told that in the field winding only we are going to inject some amount of current to the machine. So where the field coil is there in the alternator is in the rotor. So the rotor field windings are connected to an external DC supply in order to produce a magnetic field. So in the working principle we will discuss in detail. Okay. So with the help of slip rings and the brushes. By means of the slip rings and brushes. Slip ring is nothing but a rotating ring. It is fixed on the shaft. So along with the slip ring we are going to connect the brushes. So if the rotating the slip ring, we can get the current from the slip ring when it is rotating. So a prime mover rotates the rotor using the pulley or belt. That's the thing is already you may study in the power plants. Okay, how the turbines are rotating. From the turbine rotation, we are going to rotate the generator shaft. The rotating rotor generates the charging magnetic field, changing magnetic field. Already I discussed that in the Faraday law of electromagnetic induction. Whenever the rate of change of flux occurs in the coil only, it will give the electromotive force. So this varying field generates the armature winding and supplies to the load or circuit through its terminal. So where we are connecting the terminal of the alternator. So this is the actual constructional diagram for the generator, synchronous generator. Here, this is the stator. Actually, this is the stator, and this is another one stator. The two things are described in the same way, stator. But here the rotor is different. See, here the rotor is constructed in one kind, and this is for the another kind. So these rotor are called as salient pole type. So for the first figure, we are seeing the rotor is the salient pole type, and the second rotor is called as a smooth cylindrical type, that mentioned in the diagram itself. Okay, the first one is the yoke, and this is the stator frame. Actually, this is the stator frame, and this is the tooth and the slots. So this is the slot and tooth construction in order to provide the armature winding. Okay, in the synchronous generator, we are using the armature winding in the stator. So for the provisional purpose, in order to place the armature winding in the stator in a circular manner, we are having the slots and teeth construction. Okay, so the slot and teeth are mentioned in the diagram itself. So in the slot, we are having the coils wherever it is necessary, and the teeth are supported the coil when the rotor rotates. Due to the inertia, it will not come out from the stator side. So for that, we are using the teeth on the stator. So two kinds of rotor is there. One is for salient pole type, and another one is for smooth cylindrical type. So we will discuss the rotor types one by one in the subsequent slides. So this is actually the constructional diagram for the two different kind of alternators. One is salient pole type, and another one is non-salient pole or smooth cylindrical type. So the alternator is made up of different stationary and moving components. Okay, what is actually having? We are having stator and rotor. So stator is the stationary one, and the rotor is the rotating one. That is the mobile component. Each serving its own purpose. Okay, the components of the alternators are given below. Normally we are having the rotor. The rotor is the rotating part of the alternator. Okay, rotor is the rotating part of the alternator. It is made of in a cylindrical shape. Maybe it is a cylindrical shape or projected pole type, salient pole type. Okay, that has copper windings, also known as the field winding. Copper winding is nothing but the field winding, because the armature having the field windings. Then the generators generates the necessary rotating magnetic field when rotated. The rotor has the shaft that has rotated using the drive belt pulley or pulley system. Okay, so that has rotated by means of pulley. Okay, we are having the magnetic field in the rotor, and it will rotate by means of the pulley. So yeah, the source that rotates the rotor is called prime. So which one is going to rotate the rotor? We can call it as prime mover. So it can be anything such as engine, water turbine or wind turbine, etc. Okay, so this is the thing in the rotor. Then there are two types of rotors used in the alternator synchronous generator. One is salient pole type and another one is smooth cylindrical type. Already I am discussing in the diagram itself. Salient pole type or projected pole type. Okay, salient pole type first one is or projected pole type. Then second one is smooth cylindrical type or non-salient pole type. Smooth cylindrical type or non-salient pole type. Then in the components of alternator or AC generator, we are having the salient pole type rotor. So it is a type of rotor that has large number of projected pole or projecting poles mounted on the core. Mounted on the core, made up of magnetic laminated steel. So this rotor is made of magnetic laminated cast iron steel or laminated steel or cast iron. So the term salient refers the projecting as shown in the figure. So around the circular shape we are projecting something. Here we are projecting the poles. At the edge of the projection only we are having the poles, north pole and south pole, that is mentioned in the diagram itself. So this is the poles actually. This is the poles. So in the cylindrical surface we are having some projection. At the end of the projection we are having the pole. That's why it's called the projected pole type or salient pole type alternator. That is rotor. So the salient poles are made of laminated steel or iron cast or good magnetic properties to reduce the eddy current losses. In the magnetic terms we are always call it as the hysteresis loss and eddy current loss. Some magnetic losses is always happen in general. So in order to reduce the losses, eddy current losses, the salient poles are made up of the laminated steel or iron cast steel. So lamination is only for reduce the hysteresis as well as the eddy current losses. So the pole shoes have the multiple slots or for damper winding that helps in preventing the hunting effect. The field coils are mounted across the poles and then connected in series. The field coil is energized by connecting its ends to the separator DC source through the pair of slip rings. The slip ring and the brushes are mounted on the shaft of the rotor. So already discussed that the field coil is placed in the rotor only. So in order to inject the current, small amount of DC current, in order to produce a magnetic field around the armature coil when it is rotating, a small amount of DC current we are going to inject. So for that we are using the slip rings and the brushes. From the external source we are going to inject the currents. So nowadays the recent trend we are using the brushless alternator that we are discussed later. Then the salient pole rotor has a large diameter. That is the main thing. Okay. So we are having two different kind of rotors. One is salient pole type, one non-salient pole type. In the salient pole type, the diameter of the rotor is large than the smooth cylindrical type. So from the diameter itself, we can analyze that the speed of the projected pole type machine is somewhat less than the smooth cylindrical type. So the smooth cylindrical type run faster than the salient pole, large diameter rotor. Okay, so they are used in low and medium speed alternators. For the large diameter alternator, that is rotor, we are going to use the low and medium speed alternators such as the hydro power stations. Okay, in the hydro power stations we are using the salient pole type alternators. They are not suitable for high speed due to the increased windage loss at high speed. Okay, so in between the projected pole we are having the large air gap. Okay, large amount of air gap. Suppose it is run faster, windage losses occurs. So in order to avoid that, we are using only the low and medium speed alternators. Then its design does not have enough mechanical strength and handle high speed. So projected pole is not suitable for high speed applications. Then cylindrical type alternator, that is rotor. So such type of rotor has a very few 2 or 4 poles. So the number of poles may be 2 or 4. It made up of a laminated sealed cylindrical. So all the rotors are made up of laminated sheets only. Okay. So the cylindrical rotor has slots for field winding that is connected in series. The poles are left unslotted as shown in the figure below. Okay, that is unslotted. So the remaining things is for the copper or damper windings, and the poles are not a slotted one. So this is also known as the non-salient pole type or round rotor type alternator. A few are non-salient poles. Therefore, its rotor diameter size is small while its axial length is very large. So compared to the salient pole type, in the salient pole type we are having the large amount of diameter, large value of diameter and small axial length. The length of the rotor is somewhat less, but in the smooth cylindrical type the diameter is less but the axial length is somewhat high compared to the salient pole type rotor. So in the cylindrical design provides a mechanical strength, robustness and uniform distribution of the magnetic field. It has a lower windage loss, therefore it is suitable for high speed and noiseless operation, especially in the noiseless operation. So there are designed for high speed alternators such as in the thermal power station. So in thermal power station we are using only the smooth cylindrical type, whereas in the hydropower station we are using the salient pole type alternator. Here we are something discuss about the stator. So the stator is the stationary part of the electrical machine in the alternator. That is, we are already known that one. So it is used for holding the armature winding. Already discussed that the armature winding is placed on the stator only. Okay, so that generates the induced EMF. So the core itself is made up of laminated steels or cast iron. So wherever it is necessary, we are going to use the laminated steel sheets in order to reduce the hysteresis as well as the eddy current losses, for the good magnetic quality to reduce the eddy current losses. Okay. So the rotor that carries the field winding rotates inside the stator without physically touching it. That is the main thing. By means of, that's why in the alternator we are saying that according to the Faraday law of electromagnetic induction, okay, without touching the armature winding, if I am giving the supply to the field winding, by means of the induction, it will create the, or if it is a closed circuit, the current is flowing, or electromagnetic force is producing. Electromagnetic force is producing. So this is the stator construction in a separate view. The combined view is already, we are seeing that the parts are discussed here. What are the parts we are having in the alternators one by one. Okay. Then the working concept. So the alternator or the synchronous generator works on the principle of the Faraday law of electromagnetic induction, just like in other AC generators. Okay. So it states that, I already told that it states that whenever the current a conductor moves in a magnetic field, and EMF, electromagnetic force or current is induced in the conductor, which can be found using the EMF equation. Okay, so in the later on we are going to study the EMF equation of the alternator. So the conductor placed in a varying magnetic field, that's the main point. So this is a varying magnetic field. If it is a constant magnetic field, there is no EMF we can generate at the armature coil. Okay. If the field winding or field value is varied only, we can get the supply. Okay. So the field is also experiencing the EMF and is used in the alternator. So this is the main concept of the alternator. So here we are having the north pole and the south pole. Okay. So in between we are having the conductor, and this is the slip rings, and we are connecting the external source, whatever may be external load, whatever it may be, we can connect it here. So in this construction it is mentioning it will generate the AC supply and directly that AC supply given to the load. Okay, in which way it will create the AC supply? Faraday law already says that whenever the current carrying conductor, this is the current carrying conductor actually, this is the current carrying conductor actually, this is the north pole and this is the south pole. So in between we are having the tight magnetic field. Okay, in between we are having the tight magnetic field. So in this magnetic field we are placing the conductor, and I am going to rotate the conductor means, okay, if I am going to rotate the conductor means the magnetic linkage of the conductor changes time to time. Okay, the magnetic field linkage. So here we are having the north pole fluxes and here we are having the south pole fluxes. So from the north pole to south pole, fluxes always move through. Okay, so by point to point the flux linkages of the coil may differs. Okay, suppose this coil in the vertical position means, that time the flux linkage is different one. If it is in the horizontal way of placing means, that time the flux linkage is different, because suppose I am considering the right side of the coil. Now it is in the nearer to the south pole. If I am considering the left side, it is nearer to the north pole. When I am rotating the coil, the north pole linkage coil come to the south pole and the south pole linked coil come to the north pole. So the linkages are different in this way when I am rotating the coil. So the linkage is difference means actually the flux value also differs in the coil. Automatically the electromagnetic field is produced in the rotor coil, that is the armature coil. Okay. So this is the basic constructional details of the alternator. But in the normal alternator we are having the armature at the stator and the field at the rotor. This is the basic principle diagram of a alternator. It's the working principle. So this is the right hand rule. Okay, so for the alternator always we are going to mention the right hand rule principle. Why we are going to mention the right hand principle? Suppose we are having the magnet, in between the magnet we are having the coil. I am rotating the coil. I am says that I am rotating the. So whenever we are rotating the coil only, we can get the generation. So in which way we are rotating? Suppose if it is a single coil, in between the poles we are having the single coil, whether I can move upwards or downward. Suppose I am moving the coil in the upward means what is the current flow inside the conductor. When I am moving in the downwards means what is the current direction in the inside coil. Okay, that thing known by means of the Fleming's right hand. Suppose this is the north pole, my right hand is north pole and my left hand is south pole. If I am placing my finger is like this, this is the north pole to south pole flux linkages. The forefinger indicates the flux direction, north pole to south pole. And this forefinger, the middle finger, okay, this middle finger indicates the current direction and the thumb indicates the motion of the conductor. So in which way I am going to move the conductor, whether I am going to move the conductor in the upward direction or in the downward direction. Suppose this is the north pole and this is the south pole. I am placing the conductor is like this. Suppose I am going to move in upward direction. So what is the position of the right hand? This way. So this is the motion of the conductor upwards, and this is the flux direction north pole and the south pole, and this is the flow of current. So from your side, if you can view, means from yourself to myself, the current is coming from yourself to myself. This is the north pole and this is the south pole. The conductor is moving upward, means the current flow from you to me. That is the main thing. Current flow to you to me. Okay. So you are one point and me is another point, means the conductor point, means the current is flow from you to me. Suppose the conductor is moving downwards, again the same direction of field flux. This is the north pole and this is the south pole. The current motion of the conductor is downward, then current is in the outside from me to you. From me to you. This is the main thing we are going to know when we are discussing the working principle of an alternator. So based on this current direction only, the alternating current concept is begins. Based on this current direction concept only, the alternating current concept is begins. Why? Now I am telling only the single turn, only the single coil. Okay. So single coil moves an upward downward, means the current direction going to change. Suppose I am using the turn of the coil, okay, like in the diagram. Like in the diagram, so this is the turns, okay, so this is one coil side and this is the another coil side. This is the another coil side. If I am rotating the coil, the left side coil is move upwards. I am rotating in the right direction, okay. My right hand side I am rotating, means, okay, forward direction I am rotating, means the left coil move upwards, the right coil move downwards. So the left coil move upwards, means current flow from down to up. So in this direction, from here to here. Here in the S side coil, okay, S pole side coil, top to bottom. Okay, here the left side coil bottom to top and the right side coil having top to bottom, current direction top to bottom. So in this way the current is circulating among the coil. In this way current is circulating among the coil. So from this we can say that in this coil side, when it is in the north pole side, this left side coil is in the north pole side, current flow from bottom to top. From the diagram view I am saying bottom to top. When it comes to the south pole side, the same coil side comes to south pole side, the current flow from top to bottom. Why? Because the coil moves from top to bottom. Coil moves from top to bottom. So current move outwards. Okay. So in this way the alternating current is generated. So the current is altered time to time when we are rotating. When we are rotating, the current varies time to time or it changes its direction. For example, one man is walking in the inside the room from wall to wall, from wall to wall. Suppose he is starting his journey or he is walking from one side of the wall to the another end of the wall, and it will take some time. After a particular time, he is returned back to the initial position. He is returned back to the initial position. He is doing his work until we stop that person. He is doing his work until we stop the person. Like a way, if I am rotating the rotor, if I am rotating the rotor coil, it will create the current but in the opposite directions. First, some of the time or some of milliseconds we are having the forward direction of current. After some milliseconds we are having the negative direction of current. So in this way we are getting the alternating current. Okay, so this is the working principle of an alternator. So that's why we are always going to listen about the Fleming's right hand rule. So generator purpose we are using this Fleming's right hand rule, and for the motor purpose we are using the Fleming's left hand rule. So that's all about the alternator concept. In the next video we are going to discuss some other topics. So thanks for listening. Thank you very much.